Hey, it's Brad, Useful Aircraft. Tonight I want to show you something. It's a little FPV twin. A little pocket rocket I like to carry around in the car with me. It flies on a pair of 3500 kV 1407 motors turning Gem Fan 3052-3 props. They're the same props that I use in my small FPV builds. The single engine pusher, the plank if you remember, flies as well on one of these. This is a 3S 850 battery, which is what that DJI 04 system really likes to use. The upside of this airplane, it's a simple, quick, easy build. Fits in your car. Fits in, I stick it in the front seat of my car and just leave it there ready to go. It is bare bones simple for a twin, but it's got all the performance in the world because the thrust to weight ratio makes it an absolute riot to fly. Tonight we're going to build it, and I'm also going to put the 3D printed files out so you can do the same thing. So let's take a look at it, and we'll go from there. First off, like I said, on a 3S 850, all up weight comes in at about 295 grams. I have built an airplane that was sub 250 and flew it on a 3S 550, but again, you're talking flight times of about 3 minutes. I really didn't get a kick out of that. 5 minutes seems to be pretty good for me. It depends, again, how aggressively you fly it, but it works fairly well. The airplane's unique in that with 3 servos, it does become something you can play with, flaps and ailerons and crow braking and all sorts of things. It's got some flight control logic you can play with, and that's something I really enjoy, as opposed to airplanes, that might be running on just simply 2 servos. Sometimes you feel somewhat limited in what you can do in terms of, bringing the airplane down in a quick descent. Whereas with this, you can drop those ailerons down, or you can pop them up in reflex and do the same thing and counter it with the elevator. The only caveat, the elevator does have some induced flow. It obviously has plenty of organic airflow as well, but the induced flow really gives it some great power steering effects as you're flying along under power. When you pull that power off, however, you do notice that the elevator effectiveness obviously comes down. Still trims out conventionally, flies great. It is my KFM airfoil. It will drive some folks crazy. I haven't done anything to tidy the wire up. Again, this is a quick and dirty little build there. But it flies well for what it does. So let's go about starting the construction and deconstruction business simultaneously. What I want to show you first is show you the parts. Come on down here. Got the parts laid out on my workbench here. You can just see this, for example, is the wing. The wing half I have broken down into a 3D printable sub 200 millimeter file that prints out just like this. You can take that, unfold it as such, trying to do this one-handed, there we go. And you can see the template as it lays out on the wing. You can use an X-Acto knife on a piece of foam board and trace that out, or you can use a pen, cut that out, line it out first and then cut it. I only print half the wing because the other half obviously is simply mirrored just like that, and it's good to go. So that's why my templates only cover one wing or one half of the fuselage. Similarly, here's the fuselage. It's 2 pieces to, again, stay within the 200 millimeter by 200 millimeter print bed that most printers have. And as you can see, it has little pin marks. If you can see that pinhole just there and there. And those are helped to define the fold lines. The fold lines will be straight lines. I'll show it to you on my cut version here. These are the fold lines, and we will use exterior folds with those in order to form our fuselage. If you follow my templates, let's get the dirt off there. Follow my templates and turn around and trace these out and cut them as shown. As you can see, you can print just half the way that I do, or if you wanted to, you could print another set of these as well and have a template for the entirety of the fuselage all in one go. This is the forward hatch cover, which incorporates the camera mount, and you'll see how that goes together. These are 2 reinforcement foam board pieces that are used to reinforce the tail. The tail is made up of these 2 rudders, twin rudders, which is something I really enjoy. And it's difficult to see, but on the 3D print, there is a small index mark just at the tip of my thumb. I'm not sure if you can see that tiny little hole. I'll actually make it bigger on some of these 3D prints. And that's your takeoff indentation, your takeoff trim setting. It's a indentation, gives you an idea where to set your elevator on takeoff. Here's your elevator, speak of the devil, and same thing, that's the foam board piece that I cut. On my foam board pieces I put a reference for where we put popsicle sticks. Same thing on the wing, I'll have a popsicle stick back here on the tail, and then also there on the wing. Again, I'll show it to you on the airplane here. Underside of the fuselage, there you can see that popsicle stick is glued to the elevator just in front of the hinge line. I usually do it right in the middle of this tab here. You can see it is centered on that tab. My fingers are holding the forward and aft boundaries of the tabs, and the popsicle stick will be centered at that location. In the wing itself, as you can see here, that popsicle stick is just lined up here. And same thing, there's small dots on the 3D prints that will outline and show you where the ends of that popsicle stick goes. It's a little easier when you see them in hand. Honestly, it's difficult to, as you could tell with that elevator and with the elevator tab marking that I have here, it's very difficult to see. I don't even know if you can get that tiny little pinhole that's in there. I'm going to make those bigger on the STL and the 3D printed files. There are a couple of control horns you're going to need to fabricate, or control rods rather. And yeah, some folks say this is a rather long control run. I've flown many versions of this airplane, and it is a bash about, and it's given me absolutely no grief with it. So, you know, but same thing, get yourself a nice pair of pliers in order to bend yourself some control rods. I use the flight control bending tools. Let me see. These are available online. You can find them eBay, AliExpress, any of those places. And they make bending your control horns simple and precise. Your control rods, rather. So, again, all the 3D printed elements are going to be available. Download on my website at usefullaircraft.com. Let's go ahead and start building up the airframe. Bring it down to the work surface. I'm going to simply take away the actual 3D printed parts and just work with the paper for now. Clear our workspace. We'll start by printing out the wing. We have the wing here. Let's install that popsicle stick. Again, same thing. I'll have a series of dots cut there so you can see where the ends of the popsicle sticks will go. It's just behind the centering tab cutouts and just in front of your elevator servo. So, same thing. Popsicle stick just goes in there. I use a 1, 2, 3 block. I'm going to hold this down. There we are, just like that. Bring it down to the work surface so you can see what I'm talking about. Camera's misbehaving a little bit there. So there we go. Let's do the same thing on the elevator. Remember, I have these marks here showing where the popsicle stick goes. On the 3D prints, those have small cutouts, little circles you'll see, and those will indicate where the popsicle stick will be centered. And again, these are just using standard craft sticks, popsicle sticks, or whatever it is you find suitable for reinforcement like this. It helps to absorb some of the bending moments. That's the point of these popsicle sticks, just like that. A little bit of external reinforcement. I tend to try and use readily available, inexpensive build components, and popsicle sticks are something I enjoy. I buy these boxes of them, you know, online, thousands at a time, and cheap and good to go. All right, so we have these right now. Should be set in terms of on my wing. I'll pull my 1, 2, 3 block off there. And we're going to take a look at the fold line. This is a standard convention I use in all my designs. I fold an inverted KFM fold my wings, and we're going to go ahead and use my 3D foam board tool. This is a scalloped foam board tool that I use to compress and create my hinge lines. It has 2 sides. This side, as you can see, is an 8mm wide foam board tool, and this is used to create my wing folds, the KFM folds. Opposite to that is a narrower, and this is about a 5mm wide foam board tool, and this will be used to run our hinge lines. So let's go ahead and crush our foam board along the wing. Just put it down, stay between the lines. One end to the other, do it in one fell swoop, and there we go. As you can see, we've, let's run you down it, give you an idea. That's what the wing fold should look like once we've done it. You can see there's a small cut here. This will allow me to fold this portion of the wing separate, and then this portion of the wing. Do either one, whichever way you want to do it. These dots, which are in the fold line, you can see they're circular cutouts, just like that. These two are to indicate motor center line. This is obviously a twin, and for the 1305, 3500 kV motors and the 3052, those are 3-inch, 3-bladed props. This center line will give you approximately, it's about 10-15 millimeters of clearance between the fuselage and the motors themselves. These marks here will be in the underside of the wing, and those marks there will indicate your center of gravity. So what we're going to do, we'll put some hot glue here, fold this wing, and then we'll do the same on the other side. Let me get you in position. Bring it down just like that. Get these parts out of the way for right now. Get my KFM fold ready to go. I'm going to bring maker's blocks into place, hot glue gun, and just put down a good squiggle all the way to the wingtip, just like that. And now we can just go ahead, see if you can get a little closer so you can watch this, and just fold it over. As it folds into position, I'll put my blocks on it just to help hold. Again, I'm a lazy man. I like to build these things. I tend to build my models fairly quick. None of my airframes are things that take a whole lot of time to build. Build them in an afternoon, go flying that day. So these help to hold things in position and keep things square as we glue them together and put things in place. So that's just a whole little bit of weight on it. The nice thing about these, especially on a cold night like this is going to extract some temperature out of this. So in doing so, it'll help that glue set up a little bit faster. Bring it around. Let's do the other wing. Here we are. Same thing, a little bit of hot glue. There we are. I have my 1, 2, 3 blocks at the ready. Fold the wing over. There we go. And start putting these in position. And I'll rob Peter to pay Paul. Move some of these across. That should hold that wing in place. Should be in good shape. All right. We have our elevator. What we need to do, go ahead and run the narrow side of the foam board tool just along that hinge line that's at the back end of the elevator. And there we go. Just like that, and that'll give you nice, free, and easy elevator, and honestly, even a pretty straight line at the back. So, elevator's done there. Let's go ahead and build up the tail of the airplane. In doing so, we're going to use our 2 rudders and the elevator that already has that popsicle stick hot glued in position. In doing this, have the rudders at the ready. 2 rudders will go together like this, and the tab and slot design fits just as such. See how that works? Great. So, putting this on, a little bit of hot glue, Do not glue your elevator into position. I'm just putting it in between the tabs. Don't go after the tabs. So again, just in between the tabs. Just like that. A little bit of hot glue just from there to there. See that? Same thing. There to there. Now we can take this, and I'm going to use the 1, 2, 3 blocks as well. Put the elevator in position. Through those tabs. Flip it upside down. 1, 2, 3 blocks on either side. In doing so, let's let you see. That's the tail assembly now. Pair of 1, 2, 3 blocks square to the table. Obviously we'll hold everything nice and square so you get a good perpendicular build. Everything should be looking good. I'm going to run a bead of hot glue down those interior edges. Let's see if you can follow. And now I'm going to pull the maker's blocks off the wing. Bring this up. Take these out of the way. And we have a wing. Little dirty, but she's in good shape. Sorry about that. Honestly, I just keep working. I'm not trying to make show ponies. I'm trying to make something that's a little bit fun to take out and fly on a regular basis. So our tail should be coming up and setting up well. What we're going to do is work on the tail to wing interface at this point, and we can slide the two components together. Organize things on my work surface. Get stuff in position. The tail will slide up through these guys here. It's going to be oriented like this and interface as such. Let me get a better position on the camera. Upper surface of the wing, lower surface of the wing. Upper surface of the tail, lower surface of the tail. So the two upper surfaces, we'll bring them together and mate them. These foam board pieces coming out are can be delicate. So take your time, go slow. Everything will come together. When it nests, it should fit securely just like that. Just tucking in perfectly just here and here. And that's an assembled wing and tail. So what we'll do, I'm going to go ahead, same thing, a little bit of hot glue down those edges. And if you'll notice, I'll bring you down here. See if I can get you in a position. Let you watch from an angle. I'm going to run the hot glue all the way from the back at the leading edge hinge line of that elevator, crossing my wing extensions all the way down to the end of the wing fuselage interface. I'm going to do the same on this side. Here we go. Starting back here. And just like that. Make sure everything's held snug, and it is, and we'll let this go ahead and cool for a little bit. While we do that, I'm going to move things across my work surface, and we'll build a fuselage. Take the wing, slide this just down a little bit. Step out of the way, there we are, and take our fuselage. Okay, let's talk about this. These are the fold lines as we discussed. We're going to make exterior bends, meaning that I'm going to take it and I'm going to bend this surface down like that, this surface down like that. This will be the bottom of our fuselage. This will close out at the tail, and this will be used to form part of our nose. So the wing, the inverted KFM step, will tuck into this pocket here. These, as you can see, bring it around here. These wing alignment marks will tuck in there. If you can see, there is a small mark right here, right about, that's probably 15 millimeters in front of where the wing interface tab is. That mark shows the aft limit of your glute. You will go from the curve of the KFM fold to there. The reason being is this small space will be used as a wiring pass-through. It allows you to pass the power and signal lines to your ESCs out on the wing. What's this little cutout, you might ask? Well, you remember that popsicle stick on the underside of the wing? That's where that's going to go. And everything else will line up. So let's go ahead and make our bends. Here we go. Bring it down, let you see. Grab the fuselage. I'm going to place it at the edge of the table here with this fold line, just like this. Edge of the table and bend. See how that went? Just, that's going to be the sidewall of the fuselage. We're going to do the same thing with this line here. I'm going to place it on the side of the table, just at the edge. Gentle pressure across a broad surface, and it breaks just like that. Perfect. Let's take these two tabs, and we'll just knock those guys forward. Same thing, edge of the table. I just use gentle pressure with my fingers. I'll bring you down here so you can watch up close. Just right there, gentle pressure with my fingers, and it just bends just like that. So, and again, you may not cut this on a laser. All you got to do is make sure you score the foam board, go about halfway through it, and you'll have very similar results. Put this up here so you can get a better idea of what we're doing. And I'm going to go ahead and use these 1, 2, 3 blocks and hold the fuselage just in position just like this, just as we're going to want to have the fuselage as she's mounted in the airplane. We're going to take these forward and aft tabs, and I'll bring it up so you can see it. This is why my fingerprints, as I build them like this, get all over these airplanes. I'm going to bend that up just like that, and I'm going to put little dabs of glue right in the corners and hold that just in position. And I'm going to do the same at the back. I'm just going to just glue that up just like that. So again, I'll use the 1, 2, 3 blocks, hold things in position. You can do this right side up. You can do it upside down. It's entirely up to you. I'm going to do it right side up. Bring it closer. Let you see. Sorry about the filming technique. I'm a one-man band. Little dab of hot glue in the back. Same thing in the front. Just right on those tips. And this is a trick I use. If you flip it upside down right now, it's easier to hold these down like this. I'm going to use 1, 2, 3 blocks and hold these in position. I'll show you how I do that just to, again, this is the way that I build airplanes just because I tend to work fast. So I'll use a maker's block, just hold it down like that. Same thing on the other side. Make sure the fuselage is exactly as I want it. And a 1, 2, 3 block holding it just like that. I can let this set now, and I'm not worried about the pressures it's being exposed to. So what we'll do is we'll turn around. Remember the fuselage? Never mind what we're doing on the fuselage. I meant the wing. Okay, we ran the interior lines, and we've let that cool. Let's run the exterior lines. What that means is we're going to run from the just here at the trailing edge of the fuselage to rudder interface, and all the way along just to the leading edge there. Let's see if I spin this around to give you a slightly different perspective. Here we are. Then I'll come from here. I'll do this one backwards. Just like that. Just filling in. And again, this is on the upper surface to create glue lines on either side of these joints. The reason being is this joint obviously is going to absorb a lot of stress. When you're maneuvering aerodynamically, the largest control forces will be felt, from the rudder, from the elevator in pitching the airplane, up and down, especially under power. So when we double up the glue like this, it really helps to build almost a composite structure, but we're not done yet. What we're also going to do is do the same thing on the underside. So let's flip the wing over. The underside of the wing, we have these doublers that we're going to work in. I'll refresh your memory. The doublers are just going to go into place just like this. But when we put these doublers in, we're going to want to have hot glue on both surfaces where that's going to go. And we want to make sure that we're getting a good solid bond between those, because again, this is now going to work as part of our composite structure that we're building up to help absorb the bending loads. And so it's important to get some good hot glue. Watch as I do it. I'll pull this off for now. I have the other reinforcement still in place, so I can get an idea where I want my hot glue. I want to cover this tab back here, and I want to do the interior line as well. I'm going to go straight into that. And then in front of it, and I can get an idea where it reaches down to, I'm putting a little pool of hot glue there. This way, when I put this guy in place, and I snug it, snugging it just against this point here, and hold that in position just for a moment or two, just so it cools. Keep a little bit of pressure. There we are. And just while that glue sets, we'll get a good solid connection. What are we going to do? We're also going to run lines of hot glue when we're done, and we're going to fillet up here as well. And the reason being is you're really building a composite joint to absorb the load, and this is actually becoming almost primary structure in this case. So we'll do the same on this side now. Again, I'm pulling that off. I can use this side as reference when I get an eye for where I need my glue. A little bit of hot glue here. Run down just like that. I want to put a little bit extra, especially on these back towards the tail of the airplane, because I want to make sure I get a good solid interface. And then same thing, hot glue, and I'm just referencing this side here to get an idea where I want it to, where I want that glue to cover. And then put this reinforcement in place, square it up right here with the leading edge of the rudders, and hold this, make sure we're sandwiching it nice and tight, got a good contact bond, and let that cool, holding everything where we want it to be. Nice and snug at the front. This side's already nice and cool, and hold that in place. And it shouldn't take long, especially with the temperatures we have in the garage. It's probably, I don't know, actually it's 63 degrees, I can tell you that exactly. A little bit of a cool night here in Phoenix. So, all right, this side is tacky, I think that'll hold. We'll go ahead, and now I'm going to run the exterior reinforcements on this as well. I've played with this. I've done 100 types of tails on this, and this to me was, I found it to be the most effective. Given its materials, the ease of, build, this was a surprisingly strong method when it comes to utilizing foam board and minimum number of materials involved. This was a pretty good way for building a remarkably strong tail given the materials. So same thing, this side should have cooled down. I'm going to run my exterior line all the way to the front, and my interior line. So that the point of this is you now have a sandwich. Anytime, let me bring you up here, let's talk about it. I'm the other way, sorry. There we go. The point of this is you've built a sandwich with many layers, and when you apply a bending moment at one end, you're pulling on some elements and requiring tension and compression on opposite elements. And that is what helps to make for a strong tail given the weight. I tried this before with popsicle stick reinforcements running, on the sides of this, and I was seeing a lot more weight for not as much added strength. I tried different materials. I prefer not to use carbon fiber rods and other exotic materials some guys like to get into. I just find you can throw any sum of money at this. I want to do this as inexpensively and as affordably as possible, and this has been my solution. And again, that ends up working out fairly well, and we get a pretty good connection for the wing and for the tail. So the fuselage now, Bring you back over here. Remember that? We were building that guy. Fuselage over here. I'll pull my 1, 2, 3 blocks that are holding the leading and trailing edges in place. And we should have a more or less square fuselage. So there we go. That's the back end of it. That's the front end of it. Everything appears to be in place, and she's holding herself already built up. So what we'll do, remember I told you about these small index marks. You can see the tiny little cut there. It's about the width of a servo connector, and the reason being is that's what you're going to have to pass through that. So here, I'll bring you down here and let's mate the wing to the fuselage. I'm not going to get it in this aft pocket. I'm going to work from that little tick mark forward all the way up to the KFM cut. Same thing, my little tick mark forward. Nice bead of hot glue in there. I'm going to then put hot glue back here. This back divot is where that popsicle stick in the rear end will go. And we'll run that on both sides. Take your fuselage, glue on it just like that. Take your wing, do a top-down installation. There we go. Put a little 1, 2, 3 block, and let's let that hold and get settled in position as she is. Give that just a minute, and then after that, we can go ahead and start looking at closing out the nose. Reposition the camera up here. You can get an overall view of what the airplane should look like right now, and this will be the nose hatch closeout. Back here, this U-shaped cutout you see, that's where my vent system works into play. I should have a 3D printed vent. This is also included in the 3D print files. Print's real easy, no supports needed, just placed on the bed like that. Take your nose closeout, just give a little pinch back here at the leading edge of the U, and I'll show you why. Just a little tiny pinch, and that way when you install your vent latch, it'll slide on just like this. There we go. This line here is a fold line. We'll use that in order to fold the fuselage, fold the forward hatch. This is a crush line, and that crush line we're going to do similar to the crush line at the leading edge of the wing. We're going to go ahead and crush the foam in that position and fold it over, and that becomes part of our nose. This will be glued on. Pull my maker's block off. At this point here. All right, brief pause here. Can't build an airplane if I don't have any parts. Anyway, I've been flying the living daylights out of this one, but it's time to go. We got to pull the parts out of this and make it work. Show you how I do it. This is a little bit of isopropyl. It's just rubbing alcohol, 91% thereabouts. Put it in a squeeze bottle, but I'll give you a piece of advice. If you do it, you see that tiny dot there? What that is, that's a hole I popped in the top of the bottle. The reason being is it prevents expansion from allowing this bottle to self-dispense, which is something that would be bad. So for example, right now, if I squeeze the bottle, nothing happens. However, when I hold my finger over that tiny dot, if I squeeze the bottle, and I'm going to point it at the airplane when I do, it squirts some alcohol. Isopropyl is fantastic in that it makes hot glue release. So what I do, squirt a little hot glue releasing agent, a little isopropyl just like that, and as you can see, the motor slides right off. Do the same over here. You can just see the motor slides right off. Go ahead and pull the camera system out. Be careful of the wiring. Just try and avoid putting any stress. I'm going to move this over here. I'll let you watch. Come on. There we go. You can see here. I don't teach a lot about the electronics. There's a lot of other guys that are really good at electronics and whatnot. It's something that you get a feel for how you like to build your models. I generally like to show the airframes. The airframe design is pretty interesting to me. Don't get me wrong, the avionics obviously are very important, but building these airframes and coming up with new and inexpensive way to repurpose old and used servos and motors and ESCs, or whatever I can find cheap, you know, in old Amazon sales or hobby shops or swap meets or whatnot. That's where a lot of my parts come from. I don't let anything die. If an airplane crashes, cool. I'm going to take all the parts and you're going to go flying again. I may rebuild it in the same airframe. I may build it into something totally and completely different. But, you know, all of these control surfaces, these, you know, flight control push rods and whatnot, those all get reused. My 3D printed control horns, I'm not too terribly worried about it. You know, but the, here we go, let's pull the radio out here. The antenna just pops through there. I've been using a lot of, and I'll show it to you here in a second. Pull my wiring out. For line of sight builds, these are the Beta FPV ELRS PWM receivers. I think these things are brilliant. You know, it gives you 5 channels if you use them straight up as the way they're intended, and they work pretty well. These ESCs have no BEC, so I use a separate BEC. You can see how I have that wired in order to provide power, in this case, for the DJI 04 camera, and this is one of my camera mounts. What I'll do, I'm going to be careful, make sure I keep this upside down when I put the rubbing alcohol in there, and I will release that. Also included in my 3D printed files will be this camera mount. This is my underslung 04 camera mount. There we go. Work to release that. Get some of this out. A little more isopropyl, and this hot glue by and large comes off easy. There we go. And you can see. So that's the DJI 04, or folks are calling it the 04 Lite. I've had excellent luck with these. I really like them. They get really hot, however, so you do have to give them all sorts of cooling airflow, and this mount does a pretty good job providing cooling airflow on that, whatnot. I also, I don't know, I'm mucking around with this. This camera mount, I have printed their 14 millimeter. I've created my own version of their 14 millimeter actual camera mount itself, and I actually leave the lens protector on. The lens protector tucks in underneath that. The reason being is this is an airplane that I build to do stupid things with, and I want to be able to take it into brush and weeds and grass and stuff like that, and hopefully recover that lens. So that's worked out, you know, fairly well for me. Guys say, oh, but the image quality. You know what? This is not an 04, you know, Pro. This is not the camera that's designed to go out and be, you know, the Ansel Adams of photography. This is the 03. I mean, you know, you can see a difference in the image, you know, the sensor size of the lens, the amount of light that that'll gather. You know, this is just designed to be a small, fun, heck, half the time I'm not even recording. Just take it out and go flying. So, all right, back to the airframe, back to salvaging. Same thing, go to the underside here. You can see my motors are hanging just now. A little bit of isopropyl just on the servos where I have the hot glue. And these then will just push right through. You watch just like that. I'll take my fuselage. Just remove this. Some people say it's like doing shellfish. This is my motor mount. My motor mount, same thing. As you can see, we're recovering it. There's some hot glue in the back there. A little bit of isopropyl on there. No, I'm not worried about the... I haven't had any problems with this causing any shorts. Obviously, there's no batteries around. Be very careful. Isopropyl is something you want to have an idea what you're doing. You know, it's good to be well ventilated. I do actually have a fan running in the background. I don't know. So there's a bit of airflow here. I'm in a pretty sizable garage. A little bit more hot glue and hopefully isopropyl, and let's see if we get that out. With your prints, and this is just it. Yeah, once in a while these things, you manage to hit hard enough on something, you might crack one of these. But guess what? They're 3D printed. I doubt this is 50 cents in materials. That's what I love about this stuff. You can really take it and recover and reuse. See, there we go. That's a Opto ESC. Those are cheaper. Yeah, they're the old quad style ESC. There's obviously just 2 lines coming off of that. You got your power coming in on the DC side, and then otherwise there's ground and a signal wire. I like having my ESCs hanging out in the wind. It just gives it better cooling and helps the longevity. So same thing, push this servo through, pull these wires out. Same on this side. There we go. Standard servos. This build, just like this, you don't need any servo extensions. It's clean. It's easy. A little more isopropyl on this guy. Same thing. There's servos. So we've got 1, 2, where's the third one? 3 servos. Those are clean. That looks good. This is what I do. That's my power distribution. That's 2 XT30s that I've gone ahead and built a little jig to solder those together, and then yeah, I swim the whole thing in hot glue, and that works out just well. That's my power distribution. That's the electrical system in there. Kind of reminds me of some Citation jets. Throw this stuff out. And we have avionics as we need it to go back and finish the build on the airplane we're putting together now. I encourage you to recover, reuse, upcycle as much as you possibly can. This is a hobby. You can spend all the money in the world if you want to. You know, may as well get a little bit more enjoyment out of it, as opposed to being the guy at the field, which, you know, comes up with something, brings something brand new every time. In some ways I love them, in some ways I hate them. I love them because usually when those dudes end up crashing and tossing it in the dumpster and walking away, I'm the guy that picks that stuff up and repurposes all of it and puts it into something else. I've seen more guys throw away perfectly good avionics that I don't understand why they're not willing to recover and reuse. You know, I don't let anything, until it's dead, I don't let anything surrender without me saying it's okay. So again, that's the motor. It's the 1407, 3500 kV. Not sure if you can read that. You buy these things in packs of 4, relatively inexpensive. That's a 20 amp ESC. Again, it's one of the Opto ESCs. It's one of the quad ESCs primarily. But we're going to use all these parts and put them back in the build. Sorry about that. Had to do a little bit of harvesting, but we'll get back to throwing her together now. Okay, we're back. You know, you do 1,000 of these videos, and I'll probably get better at this, but right now I'm still at the stage where I'm trying to think about where I am in the build and try and think about where I am in the video, and then you sit there and you realize you've made a logical jump, like you built up an airframe and you never harvested the avionics you needed. So sorry about that. Let's jump right back into it and I'll show you where we're at. Because I also made another mistake. That was the airframe as we had it so far. We've glued everything together. We have not put the nose stuff on. We've talked about that. Then I realized I didn't have a camera. The other thing I realized after the fact, we never rolled these hinge lines here and here. No worries. We'll do it live. Stick it on the edge of the table. Narrow foam board roller. Bring you down just to keep me honest. There we go. Put you there. Put that just along there. And just roll it in as far as you can. Actually, that's going to work out just fine. Do the same thing. Flip the wing. Would have been better to do this before I had everything, you know, all glued. Here's the hinge line. Same thing. Think about where I'm trying to put my hands. This is not the way I would normally do this. But same thing. There it is. We just crunched it, and let's see how this works. Watch. Pull you out here. Flip you around. There's the, look at that. It's going to work like a champ. Oh yeah, we're in good shape. Okay, and same thing. We got an elevator that's free and correct. All right, we got this back down. Let's do some flight control horns real quick. 3D print the flight control Horns, obviously, that's what they end up looking like when they come out together. You can see that fake sprue. It looks like it was injection molded, but you're the guy that printed this, so you know that it is not. I do that so that when you break them apart, the flight control horns look like this. Obviously, you can see this big tab sticking out. We're going to have that going to the outboard on the installation, however it is. If you remember, the servos are going to be on the top side. Let's show you this. We're going to mount the servos. The servos go here, here, and here, and the control horns are coming out the top of that. So obviously we want the control horn coming out, the actual, this part here, coming out through the top as well. So just to put them in position so I remember which way they go, I'm going to place these just halfway through. And literally I'm just using this as a placeholder, okay? Just so I know where each one of these goes. Same thing, the elevator, I have this tab offset to the side that has the most available surface area. So as you can see, this side here, the tab is going in that direction. You see how this is offset to the, I don't know, to this direction? And so because of that, that side is the side that gets the tab to help convey that force. Flip the airplane over. Let's take a look. You see how these hold them up just like that? Let's see if we can get you in a better position. There you can see all three. Take the hot glue gun and just run a line parallel down where those flight controls will go. What's going to happen, the three holes that are cut out, this line of hot glue is just going to ooze up and form a little hot rivet, essentially, when I push this flight control into position. There we go there. There we go there. Perfect. And last one here. Just like that. So from the underside you can see everybody's hot glued. Let's flip this back over. There we are. Control horns are coming through on the top side just as we want. And now on the control horn, what's going to come into play is this hole here. That large hole that's just at the base of the stock of the control horn. We're going to put glue through that from one side to the other, and that's going to create a rivet, basically, on the top side of the flight control. So you can see here, just at the base, it's just about halfway exposed through the foam board. So I'll take the tip of the hot glue gun, same thing, just put it here, and squeeze a little hot glue through there. I don't know if you can see, there's hot glue on either side of that control horn as she passes through. Here's one where we have not done that yet. Come through. A little bit of hot glue just like that. And now there's hot glue passing through. Let's do the one in the back. Same thing, you can see it there. And I'll come in just like this. And now there's hot glue passing through either side. Just trying to show you that. This is, a lot of this stuff is bullshit manipulation just so you can see it on camera. When you do this in person, it's a lot easier to get a handle on it. So anyway, we got our flight controls in there. Now let's go ahead and drop some servos in there. That'll be easy. Again, come on down. Here we are. We have the 3 servos that we just salvaged. Consider these guys are good. So this guy, place it back here. All of the wires that exit the servo, I have that going forward in the fuselage. And you'll see my servo cutouts have a little cutout at the top to show you. Anywhere you see that little indentation, that's the direction in which the wires come through. So same thing, servo comes in here. And this servo will take it, wire out the front, and it's going to go just like that. Bring it down, see if you can see it better. Here we are. Wire comes through. Wire faces forward. See that? All 3 servos are in position. Some guys run hot glue on the underside of this. I do not. What I'll do is I'll flip it over and we'll make sure those servos are being held snug. Sometimes I'll put a couple of the maker's blocks so they're resting on the metal spur gear of the servo themselves. That will hold these completely flush to the wing, and then I'll run a little bit of hot glue along the body of the servo on the underside. So let's go ahead and make that happen. I got 3 maker's blocks. You can use absolutely anything that you want to use to substitute. It can be a book, or you can just do this one at a time and hold it by hand. I'm just trying to keep the program running. So all 3 right now are resting. Here we are, bring you around, let you see this way. All 3 are resting on the servos directly over the maker's block. Not a lot of play there. So a little bit of hot glue on the side walls. Yeah, this will peel off the sticker on your servo after you've done it and recovered it a handful of times, but you know what? Cool. Again, I recycle these things so many times. You'll also find you'll have a brand of servo you like. You know, my brand is whatever happens to be cheap and available, or I already have a dozen of, and there's quite a few. So anyway, there we go. A little bit of hot glue holds all these in position. Make sure they're snug and square. Now we'll let that cool just as is. The wiring, well, our center servo, that wiring's in position already. From this servo here, which is on our left wing, I'm going to pass this just inside, and you can see that's just how you get that right into the fuselage, just like that. Same thing, running around this direction. Give you a look like that. You can see that's the cutout. That's the tick mark right there. So this area ends up being a little pass-through, a little conduit, just for this to come in. Goes just like that. Tuck some of that wire in, and we'll use a pull tool and pull it through on the other side here in just a second. I'll be right back. All right, we're back. Let's get back to finishing out the avionics. So we've got 3 servos in. We'll take our motors. Let's pay attention to the direction of propeller rotation. Obviously, that's going to be the top of the cowl assembly, and that's the underside. I have the ESC on the underside of the wing. That's where all the wiring is. So that's just the direction that I run my cowls. You can run them whatever way you want. You just got to figure out a way to get the wires tucked away nicely. So that being the case, we'll take a look. The motor obviously rotates towards the thick end of the propeller. So as I place this on the fuselage, I want to consider whether or not I want to have the propellers rotating inboard or outboard. There's 1,000 discussions about critical engines and whatnot, and I have a little bit of fun. So to be contrarian, I'm going to have them turn outboard. Yes, in theory, it could be argued this makes both engines critical, but at the same time, that's why we build these silly little airplanes. Have some fun once in a while. So again, there is a mark at the leading edge of the wing. You can see it there, that circular cutout. It's also reflected on the 3D prints, and that aligns with the center line of the engine. So I'll go ahead and align the center line of the engine where that shaft passes through, and just push the motors into place like that. Little dab of hot glue on the top will hold these in place. I use these little circles, squeeze a little hot glue in just in each one of them. Do that on both sides. And the cutout at the back, same thing. A little bit of hot glue just smeared around the perimeter, just to make sure that this motor stays well adhered to the airframe. Tractor configuration, I use a little bit more adhesive than I do in a pusher. Pusher tends to push itself into the airframe. The tractor will pull itself straight off of the airframe. Now we got to take that wiring and do the same as we did with the wiring for the servos. Let me grab a wiring tool. This is simply a rod that I just put a little hook at the end in, and I find it handy to reach in grab individual servo wires. Avionics installation obviously varies by what sort of equipment you're going through. So I won't go too deep into that. Now we'll pass and I'll try and do this, see how I can face you. I'm just looking here. I'll tuck my servo wire in. Come down through the top and grab that. There we are. And then after that, I'll turn the power wire in. And that cutout should be sized right for the XT30 that I use. I just run these power cables, run an XT30 at the end, and then I'll join those up. Same thing. I've seen guys make arguments and say, you know, in tight installations like this, you could install these motors before you join the fuselage. That is certainly an option. Because, yeah, this is, you know, you're obviously working in a small space. This is the joys of these small airplanes like this. But it's also why I'm really, you know, airplane of this size, yeah, you can fit a flight controller in it, but good Lord, how much time do you want to spend doing tiny wiring projects? So this might turn into the magic of editing. There we go. This isn't something you see Remy RC farting around with as he's building a 777 you can ride like a horse. Do the same on the other side. Got a little hot glue in this one, so it had a little resistance there. Come through in the end. There goes power. And signal. Okay. All right, so the last signal wire I just fed through was the left engine. I will take my receiver. I will put on my glasses because I am getting old. Top down, not that any of this stuff is all that fabulous. I'm going to use channel 1 for the left engine. I'm going to use channel 2 for the right. Make sure you pay attention to ground wire and where it should be positioned. Here we go. Channel 2. Now the We have to sort out our ailerons and elevator. Find, there we are. Servo wire right at the back. Obviously the ailerons, the wire length will be the same, left and right. This is my left aileron. And my right aileron. And then I have my elevator at the back. All right, now we need to hook up the power leads. Again, I'm using my XT30 splitter, so that'll be the end that my battery plugs into, and that's the side delivering power to the motors. It does not matter which side is which, since this is simply splitting battery power through it. And then otherwise, this extension is a short extension for my XT30 to the battery, but it breaks off and provides me with a power to the camera system. That's the DJI 04, and then power to my receiver. So I'll plug this in just like this, and I'll plug this into my receiver as such. Bueno. The testing of this setup, I'm not going to focus so much on the avionics, so we're just going to toss this inside the airframe right now. What I typically do, I like to, and this is just something that's personal preference, pass this antenna through to the upper surface. And then I like to glue it in place with this little cutout back here. It gives me a throwback to the old ADF antennas you used to see back in the day on planes like old Beech 18s and DC-3s and stuff like that. So I kind of dig having something like that sticking up like that. So what I'll do, I'll have that hold it momentarily. The rest of the wiring, while that's cooling off, can tuck in there. And same thing with this. And now we'll take our camera system, which we built up, and this will be our top latch. Remember, this area here, we should use our foam board roller. And I'm just using the narrow foam board roller on this, and crush it just gently. Just like that, you can see. And that hole is obviously for the antenna. Play with these parts before you do this. Make sure you're comfortable and understand where they go, but this is how the camera system will pass through. So I just did a dry fit there. Oop. Just pop my antenna out of the mount. Let me put that back in. There we are. A little bit of hot glue. Just putting 4 dots there. Slide this guy in. And just visually center that up, just like that. I'm just looking top down on that. you can see the camera system. And here's something I'll actually take time to point out. See how I have, let's look at that wire. I don't know if you can see, this is the power wire coming in. I have it zip tied to this mount here, just like that. There's a reason for that. In a crash, if this cable gets pulled, it will not pull really tautly on the actual power connector. It will instead take the brunt of that impact and apply its force in through that zip tie. And it acts as sort of a mechanical fuse, you know, to prevent damaging your boards. It's, again, something we do from full-scale aviation. So there's a little bit of slack in there. It's got some room. So, all right, this is, it's all set. So what we can do, we're going to do a test fit, slide our vent latch. Here we go. I'll slide the vent latch forward. Showed you how we put that on. Tuck this into place. And just going to get an idea. And I want to snug this back end up. I want to just put it in and slide it aft so I can see where that'll latch into position. Now remember, I'm going to pull this back out. There's a hinge here. This is this line here, okay? So that hinge, we want to make sure that we only apply the hot glue forward of that hinge line, okay? So hold this forward just like this. A little hot glue down each side. Again, just forward of the hinge line. And we can even put some on these two forward pieces here that are going to be bent down. Okay, the two forward tabs. Now, flip this over. Let's not get our wires caught in the hot glue. Slide that aft. Drop this into place and make sure that camera is pulled aft. I'll put a weight on top of there to hold that for now. And same thing, I'm going to hold these two forward tabs down. And again, I'm going to use 1, 2, 3 blocks just to hold some pressure on them. Just like that. And just like that. Let me show you, give you a little wider angle. So that shows you, this is holding the camera system hatch cover down. We can test our little latch coming back into place. That's going to work just fine. These two are being held down to round out the nose. Now we're down to basically installing our control horns. So here's my control horn. Take a measure center on center for your servo. I'll take you back, point you back, show you what we're doing. Let me get you a rough idea. And again, learn to make these. Here's a ruler. I'm showing that center on center. This control horn is approximately 150 millimeters. Sorry, 150 millimeters. So, and again, I'm using survey stake flags bought at the home improvement store. They're cheap. I buy bundles of them, and I have had zero issues. So I'll put that into place. And same thing. Line that puppy up just like that. Actually, that is going out on the wrong side. That control horn should be more or less inline and streamlined, and that's a lot better. When I was facing the other way, it looked like it was going diagonal, so it should be aligned with the slipstream. So I've done a little bit of math to try and make this work out as such. So I'll put these guys in here for our aileron. There we go. Get this guy in position as well. So just like that. We're down to a couple of screws just to hold your control rods in place. But otherwise, we've built this little twin engine drag queen. I don't know. Call it what you like. The original design, the single, I used to call it the drag queen. I used to think it was a great little airplane. It was not the most aerodynamic thing, hence that's where it got its name from, but it really endeared itself to me in its performance. The evolution of this, obviously, from the single pusher, where it used to have a motor back here, and then the servo back in the tail. That was great, but boy, that was a noisy airplane. This is a lot more neighborhood friendly in terms of its flying. So let's take a look at what we built. So coming back up, here we are. Pull the 1, 2, 3 blocks out. And that's what we've done. You can see. Let's take it out to the field and see how she flies. I think you'll really enjoy it. Hey, again, STL files for this are going to be available on the website, usefulaircraft.com. It's one of the few things you'll be able to own and make as many of them as you want. You take these pieces, trace them out. You know, you've got all the precision of 3D printing. It's just as good as a CNC, you know, and cut parts, build, repair, and fly as many of these as you want. All of these, you know, this again, that's fuselage half. You could, of course, print another 2 of these and then glue those 2 pieces together and you would have an entire fuselage template, but honestly, all you need is half. Draw out half of it. And this is the 4-piece wing template. Same thing, that's one side, draw that. As she is there, lay it on your foam board, trace that out, cut it, and then do the same on the opposite side. It works great. Doesn't require a lot of printing. It's easy to do. Foam board's fun to build with, and it's quick and easy to repair. It's something we pretty much know everything about, so I think you get a kick out of it. Let's watch some flying of this, and we'll go from there. Again, I'm Brett. This is Useful Aircraft. Thanks for your time. All right, and we're off. So there's another RC airplane flying up in the sky. I'm not the only guy out at the park flying at Dynamite Park here. It's dedicated free close to the house, makes it easy to get up and go. Doing my pattern check, making sure I see anybody else that's out and flying. Flying using the Radio Master TX12, usually first couple of turns and everything else. I'm setting my trims. I use the rollers you can keep your fingertips on. One for pitch trim, one for aileron trim. That way I can get things set up. The 2 little P1 and P2 knobs, those are great for running rigging, but we can talk about that another day. So it was a great clear day. We just had some weather move through the area, so though the winds were a little bit high, you can see that's my other buddy I just noticed flying high. So I thought I'd come around and see if I could find him again, maybe form up, do some air to air. But yeah, there was a little bit of breeze blowing. So up here as we're getting towards the top of the area, you know, I'm more or less in laminar flow. When I get down towards the ground and whatnot, you will see there's some pitch oscillations that happen because we're encountering mechanical turbulence close to the ground. You start to get a little bit of that. And this airplane, you know, obviously being just under 300 grams as we're born, you know, is susceptible to any pitch, you know, I don't know, any sort of turbulence. Mechanical turbulence tends to manifest itself mostly in pitch. You can see we just came up behind it. These airplanes are grossly mismatched. He's flying something akin to a glider. I am flying something that does not have anywhere near the wingspan. I am probably less than half of his wingspan. So he can outslow me and there's not really a whole lot I can do. It is kind of fun. The dude that's flying, great guy, loads of fun. Good Lord, flies acro like he rented a car for the Baja 1000. He's not afraid of anything and doesn't really pay attention to the way one would think a glider might be flowing and continue to remain airworthy. A little bit of Japanese tactics there, flying straight into the sun, although I still managed to keep an eye on him. It's loads of fun flying FPV and formation stuff with your friends. I really tend to enjoy it. Sometimes we just like going out to the desert and going exploring. I'll show you some footage of that later on. But here, again, no relation to which end is up. Obviously, we've got a monkey see and monkey do. But I've got a, you know, a straight wing. Again, it's probably less than half the size of what he's got. So it does make it a little bit of a challenge when he cuts his power and just chooses to act like a glider. I tend to go rolling right past him. So looped around, thought I'd look for him again, but probably get distracted here. I don't see him, and sometimes it's fun to just go out and explore on your own. You can see the airplane's pretty snappy when you want it to be, full deflection. You know, it'll give you a roll rate, probably 720 degrees a second, thereabouts. It makes it easy for maneuvering in tight space. You know, straight wing stall characteristics, fairly benign. You can power your way out of pretty much anything you find yourself in. Oh, there he is. You can see him, yep, again, doing loops like an absolute madman. Let's see if we can turn back around and catch him. We're 3.5 minutes into the flight. This is, you know, 5-6 minutes seems to be the happy spot. This is kind of a somewhat, you know, average Joe flight. I'm not really into the throttle the entire time. You know, obviously if you're sitting there and doing nothing but vertical and trying to, you know, keep it deep into the red the entire time, yeah, you'll burn through your battery a lot faster. Simultaneously, if you're sitting just having a gentle, swoopy, cruisy flight, you'll enjoy it. You know, and you probably stretch that battery out to, you know, 7 minutes, maybe even a little bit more than that. You can see I'm just outpacing him. Had too much energy, came on the downhill, ended up sliding right by him again. You know, again, he's coming towards the end of the battery. Matter of fact, I think at or around this point, he's coming around and landing. So, you know, now I'm just cruising and taking in the sights and whatnot. Can't go south of the road there. Turn back up to the north, reset myself, as we should be. You know, there's a couple of dog walkers come walking around. There's another guy. Oh, there we go. Just passed somebody there. You know, thought I'd give a buzz, say hey to everybody on the ground. That shows you what the roll rate looks like on this thing. She can come around in just about a second if you want. And again, there you can see some of the mechanical chop. We were starting to pick up some bumps. You know, that's the downside of this. If you get up super bright and early when there's absolutely no wind, these things are magnificent. But, you know, I mean, ultimately it's subject to the laws of physics when you're flying something 290 grams with a 3S battery on board, or sub 250 if you really built it light and fly it with something like a 3S 550. But, you know, any sort of turbulence, you're just going to feel it. I don't have any wing leading edge devices. You know, I do have a set of slats that I've been playing with on this thing, and also a couple of stall fences. There you can see, that's the guy we were chasing earlier. You know, those do give you some better and different slow speed, you know, high angle of attack flying that you can play with. I would say, you know, make that 3 to 5 mistakes, you know, high, because obviously, boy, oh boy, when that wing finally does snap, it can be a bit of an event if you're using those leading edge devices. But, you know, there we are, 5.5 minutes into the flight, and I decided that was enough. It was time to go home, getting too bumpy. So here we are, into a landing, and shut her down. Thanks for watching.